Monday, everyone. We're going to do the worksheet real quick. I'm assuming that you've tried them. Maybe you didn't come up with the right problem, so you can kind of forward yourself through and work with this. Notice I've got colors over here. I'm going to try to use red for the primary and all of that stuff. So you have a wall, and on that wall you have a pen that's being built. So you've got an L and an L and a W. Okay, and you're after the largest possible area in this case. So my primary equation is going to be, oops, my pen keeps moving around, area equals length times width. Okay, so I'm going to change colors now. I'm going to go green for my secondary. My secondary information deals with that I have 200 feet of fencing to use. So I know that 2 L's plus W is going to equal 200. Now, that green one needs to be plugged into the red one. Make your math as easy as possible. W would equal 200 subtract L. Oops, 2 L's. There we go. And do your substitution in. So you're going to change back to my red color, and I'm going to write my new primary equation. And it still is area, and it's going to equal that single L that I have now times 200 minus 2L. I do not want to have to do the product rule when I take the derivative, so I'm going to go area equals 200L, and then it's going to be subtracting 2L squared. Now I'm going to go and change, and I need to take the derivative of this. And since everything is in the terms of L, I'm taking the derivative with respect to L. So my area prime is going to equal 200 subtract 4L. All I did is I powered that down. What do we do to that area formula? We set it equal to 0. So negative 4L is going to equal negative 200. L is going to equal 50. Okay, so now that I've got the length, I am going to come up here and I'm going to find out my width. My width would be 200 minus 2 times 50. And I believe my width is going to be 100. So my dimensions are 50 feet by 100 feet. That would be my final answer. So moving on to the second problem. For the second problem, I'm changing back to red for my primary. The rancher wants to construct 2 identical rectangular corrals using 300 foot of fencing. The rancher decides to build them adjacent to each other so they are share fencing on one side. You guys know that that means I have, sorry about the icky diagram, best I can do on this, one fence. I'm going to call this whole side here Y, and I'm going to call this whole side here X. You could use W's and L's. I just decided to do Y's and X for something different today. So my primary equation, I want to enclose the largest possible area. So area, I'm getting lazy. I'm going to use A equals instead of the word area equals. In this case, it would be an X times a Y. An L times a W is just fine. For my primary equation, that's coming along. I've got 300 feet of fencing to use. So for that secondary equation, I am going to actually have, and I'm coming back up here to help you see it, X and X. So I have 3 X's plus 2 Y's would equal 300 feet. Okay. Again, make the math as easy as possible. You can get the X by itself. You can get the Y by itself. I did X and I did 300, subtract 2Y, all divided by 3, which I told you I would highly suggest writing it as 2 fractions. 300 divided by 3 is 100. Subtract 2y all over 3. So that's what I would have for my secondary. I'm now going to go back to my primary equation and I'm going to substitute it in. So my new primary equation is going to be area equals, that's an X. So 100 subtract 2y all over 3, and then it's times an additional y. Or my area is going to equal 100y subtract 2 over 3, and the y is squared. To that equation, we are going to take its derivative. And now, since everything is in terms of y, I'm going to take it with respect to y. And I'm going to bring that derivative up here, just so you guys know where I'm at. And my area prime is going to equal 100. Subtract, bring that 2 down. I'm going to get 4 over 3y for my derivative. And what do I do with that derivative? I set it equal to 0. So I have 100 equals 4 over 3y. Notice I added 4/3 y to each side. You could have subtracted the 100. I can now cross multiply, or I got to get rid of that. So 300 would equal 4y. And y 300 over 4 is going to equal y. So I have my y value. 300 divided by 4, I hope you guys know that that's going to be 75. Got that y value? Come back here, solve for my x value. My x is going to equal 100 subtract 2 times 75, all divided by 3, which is going to give me an x value of 50. Okay, but this question has a little kick to it. It asks, what should the dimensions use for each corral? The dimensions of the entire pen would be, if I can spell the word entire here, would be 50 feet by 75 feet. But for each pen, they're going to be, the x value of 50 is found in each, but it's going to be 50 feet by 75 divided by 2. And that's the little trick, because it's each corral, not all together. So entire, if you got the 50 by 75, that's great. The key word here is each. Okay, so that takes care of 2 out of the 4 problems. So now we're going to go to the third problem. And for the third problem, we are going to construct a box. Remember, I said I like the box problems, so make sure that you know how to build this thing. So I'm starting off with an open top box from a piece of cardboard that's 16 inches by 30 inches. Okay, 30 inches here, it's longer, 16 inches here. And now what the employee is going to do is he's going to cut out those 4 corners, and he wants to know largest possible volume. So your primary equation is going to be volume equals length times your width times your height. So there is no secondary equation, but you need to remember you're making it a square, you're making a square, and you are making a square here. And one more, if I can get them to color in. Those squares have each sides of x and x. X and x. And these x's don't look that great, but you guys know what I'm talking about. So with all of these x's in here, that now changes this dimension. This is no longer 30. This is 30 minus 2x. This is no longer 16, but 16 minus 2x. So what all of these numbers do is, for my new primary equation, I'm still going to get volume equals, but my new length comes from my green part of my picture, so that is going to be a 30 minus 2x. And my width is going to be 16 minus 2x. And now, if you actually do the folding here, your height turns into an x. So now you have created an equation that only has one variable in it, and we are going to take its derivative with respect to x at this time. So my derivative, volume equals, ew, I'm thinking, oh, this would be using product rule. Maybe I don't want to do this yet. I'm going to hold off for a second, and I'm going to say, oops, because I think I want to do some math first. I think I want to go back into red, into my new primary color, and instead of having to do the product rule with this nasty, I'm going to FOIL this out. I'm going to take 30 times 16, and I'm going to get 480, and then I'm going to get minus 60x, and I'm going to get minus 32x, and I'm finally going to get a plus 4x squared, and that is all times that lone x still on the outside. So my volume function is actually going to become 4x to the third power, subtract 92x squared, and then plus 480x. Okay, so now I'm going to switch and take my derivative. I think this looks a little bit easier to take my derivative of. And I'm going to take that derivative, so volume prime is going to equal 12x squared, subtract my 180, 84x, and then it's going to be plus 480. Okay, so there's my derivative. I set it equal to 0. I said use a calculator on this. On your calculator, because I'm not going to try to factor that. You guys can if you want. I found that I have an x value of 12, or I have an x value of 3.333 repeating for this. Can't be 12. It's too big. If you plug it in to the dimensions, too big. You can't work it out up here on the side of 16. So the x value has to be 3.33. Plug 3.3 in. So if you had 30 subtract 2 times 3.33, and then you're going to have your 16 subtract 2 times 3.33. And I believe you're going to find that your dimensions are going to be 23.334 by 9.3, oops, that wasn't by, 9.334 feet, and then it's by 3.333 feet. Okay, almost done. Last problem. Okay, remember, I like that kind of problem too. Last problem. We have some engineers, and they are designing a box-shaped aquarium with a top, or with a square bottom and an open top. So, in terms of what you're looking at, it's a three-dimensional box. So, it goes back and back and back. You should have, oops, something that looks like that. Now, they said that the base of this box is going to be a square. So I know that this is an X and this is an X, but they never said the height. It's never said it was a cube. They only said that the square is on the bottom. So that's why I have X and X here, but a different value going up for the height. It wants me to minimize the amount of glass being used. So if I'm looking at the amount of glass, the primary, let me just scratch that off. Your primary equation is dealing with surface area. Surface area is adding up all of the panes that make up that glass. So the bottom of the box is a square. X times X is X squared. That takes care of the bottom. Each of the sides is an X times a Y. So I have how many of those panes? Count them out. 1, 2, 3, 4. 4 X times Y. And that is how I came up with my surface area. So, switching to my secondary, they say that it must hold 108 feet cubed of water. So now my secondary equation is a volume, and with this volume, I don't know what just happened. Let me go back to my pen. My volume equals its length times its width times its height, and it's going to equal 108. So this V was technically not needed. I put it there so you knew that it was volume. Length times width times height is 108. So in other words, X squared times Y is 108. Now, you have your choice again to get letters by itself. I always get the easy one by itself. Y equals 108 divided by X squared. Okay, we're going to have a little math to do, but we can deal with it. So back into my primary equation. So now I have my new primary. And my surface area is going to equal X squared plus 4 times X. And finally, there's that Y value. That's 108 over X squared. Now, the algebra is where you guys usually get caught up. So let's kind of talk through some of this algebra for you. I am going to rewrite that surface area formula. The X squared does not change. Now, changing colors so you can see where some of this happens. This lone X here will cancel with one of the X's down here. And 4 times 108 is going to give me my 432 over X. But I don't want to take a derivative with an X in the bottom. I don't want to have to do low D high minus high D low, square the bottom, and away we go. So let's be creative. Let's remember our algebra rules. And we can change that X on the bottom to an X to the negative 1 on the top. So at this point is where I would be taking my derivative with respect to X. And when I take my derivative with respect to X, my surface area primed becomes 2X subtract 432 over X squared. Yeah, I did a lot of math. I powered that down. The plus became a minus. This came to the negative 2 power. I changed it to X squared here, so it was set, because now I can set this equal to 0 and solve this. So I left the 2X on the left side and changed the 432 over X squared onto the right side. I'm thinking about the idea, oops, let me change colors here so you can see it, of cross multiplying. And as I cross multiply, I'm going to get 2X cubed now equals the 432, which means X cubed is going to equal 216. And I'm going to have to take the cubed root of each side. And don't know if you guys remember your cubes. If you had me in math, you guys should be. In Algebra 2, X is going to equal 6. So I have my X value equaling 6. I need to solve for my Y value. So Y is going to equal 108 divided by 6 squared, which is 36, and that turns out to be 3. So the final dimensions would be 6 foot by 6 foot by 3 feet. And as I said, I like all of these problems. I hope that you guys don't have any issues. As I said, you guys need to be able to learn how to study for this. I am going to try to get this thing to close, and hopefully you'll be able to find it when you are done. So I'm going to go directions and turn this thing off now.